Video, do you? Okay. So this chapter is all about composite functions and inverse functions and logarithmic functions, which you probably have seen already, right? And exponential functions and their applications. And these types of functions have lots of applications. So the first thing, you go to the car dealership and they're offering you a promotion where there's a rebate of 15% on new cars. Ooh, that's a good deal. And a 15% discount on new cars as well. So Sarah, there's no Sarah in this book, okay, is looking at a new car which costs $22,500. She's trying to determine the price of the car. Write a function f of x for the rebate and g of x for the discount. Okay? Am I recording right now? I am, aren't I? So, if I wanted to do this, what could I have for the rebate? What would f of x look like? How would I do that? F of x equals what?
Minus 15.
Yeah, it would be whatever the, what should we call the original price? Let's call it like, well, I have to call it some letter. M, P, oh, yeah, but then it'll look like it's 0. Let's call it price, okay? Let's call it, which stands for the price original, minus 1,500, right? Yes? You see where that came from? So let's say it doesn't matter what the car costs. Let's just say it starts off like this particular one is 22,500. And then we have g of x. How do I figure out what that is? 1 minus 0.15, or it'd be like 0.85, right? Times something times the times f of x. Times the, let's just call it x. Let me see if this makes sense. G of x. Well, let's call this f of x. Let's call this x as well. Okay. So, well, this is what you plug in, right? So you're going to take a discount off of this amount, right? And this is your $1,500 discount. This is your percentage discount. So what they want us to do in this case is write two different scenarios. One is f of g of x, right? Which is like this, f of g of x, which means that you first get your discount and then you take the $1,500 off, right? So that says you go, whatever the original price of the car was, you plug that in there, and then you take that answer and you plug it into there for x, right? Which would be, then you'd get $1,500 off of that amount, right? Or you could do g of f of x. You remember this, kinda? Which means g of f of x means first you take the $1,500 off, right? And then you take that answer and you multiply it by 0.85. I should kind of erase this over here. So I would put the 0.85 in front, like that. Okay? Which do you think is a better deal? Which is better to do? Yeah, this is better, right? Because you're taking that, or excuse me, this one is better, right? Because you're taking that discount first, and then you're getting $1,500 off the discounted price, rather than taking the discount first, right, and then multiplying by 80 by taking the 50, because you're getting less of a discount, right? Because you're getting a discount off a discounted price. You understand? So that's the difference between, you know, this being f of g of x and g of f of x, and it depends on what order. And the car dealer probably wants you to do which one? The car dealer probably wants you to do this one. And you say, no, I want to do this one because I get a better deal. It only ends up being about a $200 discount, but difference between the two. But that's how composite functions work. So another type of composite function that we're going to move on to is an oil tanker. An oil tanker is leaking oil in such a way that the radius of the circle is decreasing at a rate of 3 feet per minute. The area of the circular oil patch created is a function of the increasing radius. Write a function for the radius where time is in minutes. Who can tell me that? R of t. R of t? R of t? R of t? Hello? 3t. Very good. Who said that? Very good, Julia. 3t. So R of t because the radius of the circle is increasing at a rate of 3 feet per minute. So you just multiply the amount of time times 3 and you'll get the radius. Write a function for the area without respect to the time right now. So it says the area of the circular oil patch is a function of the increasing radius. So how do I find the area of a circular oil patch? You know this. How do you find the area of a circle? Pi r squared. Okay? So now what they want in the next section is they want a function for the area in terms of the time. So this is the radius in terms of the time, and this is the area in terms of the time. So how can I come up with a function for the area in terms of the time? Right. Emma, what did you say? Good. You take 3t and you plug that in there. So this is like f of x, and this is like g of x, so it would be f of g of x, or it would be a equals pi times 3t squared, and then you could simplify that. You have to square 3 and then square the t, so you get 9 pi. You kind of want to write the numbers out in front of this variable back. So that would be that in simplified form. You get that? Okay? Now a lot of times when you'll get the calculus next year, but if you have something like a function inside a function, like f of g of x, yet they'll ask you to take the derivative, find the rate of change with respect to time, find the rate of change with respect to the area, and all this kind of stuff. So composite functions become very important when you're doing calculus stuff because different things are changing at different rates, and it's kind of fun and important when you get there. All right, so now we get to do some word problems. I mean some non-word problems, because you don't like word problems, right? You like word problems?
No.
They just, wait, I have to tell you a story. Am I still recording? Yes. Oh, I can't tell you a story then. Next time. No. I don't know how to get my recorder back. Oh, tell you a story. It's not a story. Sorry. Okay, so we're going to go back and we're going to teach you how to do this problem. F of g of 1. Do you guys know how to do that? You've done this before, I think. So all you do, f of g of 1 means you take 1 and you plug it first into g. So this is the same, this means the same as f of g of 1, like this. Got it? And this thing inside is called the inside function, and this thing outside is called the outside function. That becomes really important too when you do something called the chain rule. When you take, most of you will take that. Okay, so you take 1 and you plug it in here, and then you get out that answer and you plug it in here. All right. So what does f of g of 1 look like? For us, what does f of g of 1 look like? minus 3, 29. You guys get where that comes from? Logan, why are you writing down anything? Oh, you get this? Okay, well, pay better attention though. Okay then, Logan, I don't want to embarrass you. Logan, which Logan? Okay, what's G of f of 1? I don't know. Logan Shapiro, what's G of f of 1? Is that right? Yes, it is. Does everyone see where he got negative 4 from? Okay? You take 1 and you plug it in here. They get out negative 1, right? And you plug it in there, and that becomes negative 4. Who can tell me what f of negative 2 is? That's a little more tricky here. John wants to tell me what f of negative 2 is. I don't know. 47. I think that's right? You take negative 2, you square it, you multiply by 2, so that'd be 4 times 2, right? Which is, I know what that is, 8, don't tell me. 8. Yeah. Minus 3 is 5, so you get out 5, and then it says go through that cycle again. Take 5, stick it back in there, right? 2 times 5 squared minus 3, and you get out 47. Way to go, JP.
Yeah.
Woo! Hey, that's my best friend. Okay. G of negative 1. Take that, plug it in. Get out negative 1. Plug that back in. What do you get out? Negative 4. What? Oh, sorry. Negative 4. So you get out positive. What? Sorry.
Positive 16.
Come on. Negative 16. Come on. Teachers now. Any questions on that? No. Good. All right. So moving on to the next thing. F of G. So this is a little bit different in that you have to plug in entire function in for F and G. Okay? So, and I think you've done this as well. So if I take this entire function and plug it in here for both x's, right? That's called f of g. And so what that looks like, that's 2x plus 3 squared, right? Plus 3 times 2x plus 3 and minus 1. And then you simplify that. A lot of you don't know what this is when you FOIL it. What do you get? 12x plus 9. Don't forget those middle terms. Plus 6x plus 9 minus 1, which is equal to 4x squared plus 18x. 9 and 9 is 18 plus 17. Questions on that? Okay. And g of f works the same way, except I take this function and plug it in here. So what that's going to look like is 2 times x squared plus 3x minus 1. My 2 times plus 3, right? And whatever that simplifies to, that simplifies. Okay? So it's important to know that, like, where if you were to, it's just important. What's the domain of each? Can x be any number? Yes, all real numbers. All real. Domain. Because you could plug anything in here, because they're both polynomial functions, and so the domain is all real numbers. Okay? Questions yet? No questions yet. Next one. So this says show that f of g of x is equal to g of f of x. So again, what you do is you take g and you plug it in here, and you take f. What? That looks what?
Hard.
It looks hard? No, it's not. Good. So So this one says take this and put it in here. So if I did that, I go 3 times, and I plug this in, which is 1/3 times x plus 4 minus 4. Yes? Does everyone see what I did? That's a minus 4 there. Does that look like a minus 4? Looks like it's stringing. There you go. There's minus 4. Got it? And so what happens to this 3 and 1/3? Go away, right? And you get x plus 4 minus 4, which is x. So that left side is equal to x. Right? So now I'm going to go the other way. So I'm going to take f and plug it in here. So that looks like 1/3 times 3x minus 4, correct? We have 1/3. Oops, I need parentheses. 1/3 times 3x minus 4 goes in there, plus 4. What happens to my 4s? You can cancel those out, right? And I get 1/3 of 3x, which is x. So both sides equal x. So is f of g of x equal to g of f of x? Yes. Yes. And what we'll learn in the next section is that if f of g of x is equal to x and g of f of x is also equal to x, then they're known as, anyone know what they are? Inverse functions. Very nice. Brett, they're inverse functions. Okay. Good job, Brett. Yeah. John, I'm going to say your name on the internet and send this message to your parents that you're surfing the internet during class.
I don't know. They're going to wait for the entire lesson.
Yeah, I'll tell them where to go.
Oh, okay, good.
Okay. Okay, next. This is a little... What are you doing? Spinning rings. What are they spinning rings?
Right here.
Brett, I take back all those nice things I said. So, this one is a little bit different in that you're going backwards. So what you're supposed to do is look at this function, basically, and break it apart into 2 functions such that one of those functions is f and one of those functions is g. So who can tell me what might be f of x? Anyone have an idea? No, I don't want to get f of x. Nice. Good. 1 over x. And g of x, therefore, Maddie, would be what? Nice. You guys have probably done this before. So if f of x is 1 over x, and g of x equals x plus 1, then h of x, right, would be f of g, or which is equal to f of g of x, right, would be what I get when I plug this one in for x over there, and that would look like 1 over x plus 1. You understand that? You're going backwards. Okay, so you're breaking this apart into 2 separate functions. See that? Okay. So for instance, like another thing you might see is like sine of 2x. What would be? How can I say I said y equals sine of 2x? What can I do? F of x would be sine of x, and okay, stop. And g of x would be what? 2x. And something like this and then I could write this, that y is equal to f of g of x. And this becomes really important when you're doing calculus because the derivative of this, you take because it's something called the chain rule, you take differently than you use a different rule to take the derivative of this. And you have to take the derivative of the outside function, the inside function, and you have to understand that there's 2 functions going on here. One which is to take the sine of something, and one which is to multiply it by 2. Okay? All right. So this next one is kind of tricky, and I like this one. Hey, stop all your side conversations against the rule. So Find the domain of f of g of x. Anyone think they know the answer to that problem? What's the domain of f of g of x? John?
Don't we just put the g of x equations on the x for
You could do it, but you're still going to miss out on something. Because, look, so if I want to do the domain of f of g of x, this is the same as this. What can x not be here? X cannot be 1. But there's also something else that x can't be. Not negative 2. It's the number that I plug in here to get out negative 2. Because what I'm going to do is take that number and plug it in here, right? So, yeah, is it negative 7?
Yeah.
Well, no. So what you have to do, okay, what you have to do is say what value for g of x is going to make f of x undefined, right? So what output out of here, or what value of x is going to make this negative 2. So you could do a little equation, just set negative 2 equal to 1 over x plus 2, like that. Because this is the value that will make this function undefined, but you need to solve this. Whoops, why did I write a plus 2? That's wrong. I should have written this as, this should be x minus 1 here, right? So I want to know what value when I plug in for x will give me a negative 2, because if I plug in negative 2, this is going to be undefined as well. So I cross multiply, I get negative 2 times x minus 1 equals 1. Any questions on what I did algebraically there? I distribute, I get negative 2x plus 1 equals 1. Did I do that wrong? Plus 2, sorry, plus 2. That's what I did wrong. I get negative 2x equals...
Wait, isn't it 4 over x minus 1?
Oh, that's what I did wrong. I'm sorry. So that's a 4 over here. That's a 4 over here. Making lots of mistakes. So that's negative 2x equals 2. So x equals what? Negative 1. So this is the other thing that x cannot be. Okay? So there's two values that x cannot be. There's a value where the inside function is undefined, and then there is the x value that's going to make the outside function, the x value of the inside function that's going to make this function undefined. See? So doing the next one, let's do the next one. Okay? So if I wanted to find g of the domain of g of f of x, okay? So g of f of x. So that means that f is the inside function. So right off the bat, what could x not be? X cannot be negative 2. And then what value, if I plug it in here, will make this undefined? 1. So what I do is I set, so f of x cannot be 1, right? So you can go, 1 over x plus 2. You don't want that to be 1, right? Positive 1. So I cross multiply, I get 1 equals x plus 2. X equals negative 1. So the other thing that this can't be is x can't be equal to negative 1. Oh, that, right? So that's kind of a tricky one. And you don't want to really take this and plug it in here because, or vice versa, because then you're still going to lose one of these two things. All right, last one, and these are my favorite ones. Because they're fun. They make you think like, hey, these are, what's your problem? These are fun problems. Look, what you want to do is they give you a table of x, f of x, and g of x. And these are important because A, you'll see them, again, and B because they do come up in calculus again a whole lot. And Mrs. Hine told me, oh, these kids had a hard time with this type of problem. Instead of calling this f of x and g of x in calculus, we would call this f of x and this the derivative of f of x. Anyway, so you'll see when you get there next year. They're my favorite types of problems. So what this means is, because they're conceptual and they're not really very mathematical, right? What is g of 1? Look up here. G of 1. What's g of 1? 0, right? And then what is f of 0? Yeah, so you go up here, and when x is 0, f is 5. And so the answer to that is 5. See, that's not near as bad as it looks. So f of g of 2 says, let's see, first we go to 2, and we plug that into g, and we get out negative 3. And then I take that negative 3, and I plug it in for f, right? So I go over here, and what do I get out? 11, right? So this is 11. Sometimes when I move back here, my movie board gets kind of out of control. But maybe, you have alien interference? Okay, g of 2, last one, and then we'll be done. Okay? G of 2. So what that means is take 2 and plug it in to g, negative 3, and take that answer and plug it back in for g, and what do I get out? Negative 8. You understand? So those conceptually, they're kind of fun, but people don't know what this means when they do it. So that's the end. Okay? And your homework is right there. Yay. And you can start, and remember you heard it here on, no, on the, so there